Start. So this is also running. Bhaskar can make sure that it is running always, this one. All right, so let us start. It's a bit adventurous class. I mean, in terms of the technology, everything we are going to combine now. And please practice. What I'm going to do today is for Mac, and somebody please take it up, the challenge of doing it on Windows, and let me know how you are doing it, either Devraj or Ravi, whatever is there. All the concepts, everything is going to be same, but only thing is that the platform is going to be different. Okay. So what we are going to do, we are going to create a Spark cluster, a complete cluster with a master and with so many workers, and we will run that Spark cluster on this particular machine. No virtual machine at all. We are going to create from scratch. From that, you will master the whole idea of containers. And the moment you know what is meant by a container, tomorrow if you want a Hadoop to be installed, you will never touch your system profile. You are going to create a container for Hadoop, you run Hadoop. You want to create a master and 10 nodes, you will run the container for that. And then you will run Hadoop. So your system will be always clean. Anytime a new version is coming, you will just create the image of that new version and you will start running. So we are going to see everything, right? And once I give that particular thing to you, you can practice on your own, and I will give you that additional material that is remaining for Spark, and I will introduce you to the data frames today, okay? So that the whole week you can practice it. And tomorrow, the next Saturday will be the last class where I will be covering you the applications, the real life applications that I have done, which will not be recorded, which will be just explaining you from my laptop, okay? So cannot be recorded at all. So that I will show you to give you a feel of what is really Spark doing in the outside world. But before that, you please practice whatever is there. Hope you're all familiar with RDDs. If you have not practiced it, data frames, whatever I'm going to take today will not be understood to you in any way. So you'll have to just bear with me. What's a container? That's the first question, right? If you have an operating system, right? If you have an operating system and assume that there is a software we are installing on the top of it called hypervisor, and if that hypervisor is allocating something dedicated for some box, another operating system, by taking the RAM, CPU, all the capabilities of your host system, which is your host system, the Mac or Windows, the hypervisor will take some CPU, some memory, and this hypervisor will create that particular thing, is called a virtual machine. Whenever you are running a virtual machine, that virtual machine is taking the CPU and the RAM and the power of your laptop and keep it dedicated. And that's where you played with your Cloudera or Hortonworks virtual machine so far. It always allocates, if you remember the first class where you installed it, you will tell 2 GB, 3 GB is the RAM, how much is the CPU, you will drag how much is the memory, all that if you remember. And you will tell that you want bridged mode, which means that if this is having an IP 10.0.0.15, this will be 10.0.0.14 kind of thing, and it will be bolt connected to your internet, which is PassionBytes. So this hypervisor is allocating this thing. What's the problem? Whatever you are doing inside this is completely dedicated to this virtual machine. That's all. I cannot take this virtual machine and give to Ravi from Bhaskar. Not possible. That virtual machine is his Windows machine, and inside that there is a hypervisor. His virtual machine is running inside that. Your virtual machine is different from his virtual machine. His virtual machine is different from the third virtual machine. Virtual machines are not portable. It is like a tightly coupled application on the top of your computer. The people started thinking, assume that in the old world you are making a house of yourself. Not on the old world, even today also the people make their own houses. Buy a land, buy a house. That house is not portable. That house is permanently on that particular land. Instead, if suppose I am creating a mobile home, wherever I go, I can carry that mobile home along with me. In the real life, we have seen that. Apply that into the software world. Rather than making this virtual machine tightly coupled, call this as a container. Just like you run your Excel or Word or those kind of applications, run this container as an application, like a Java program or something. Java program, if I run, it will run like an application, and then I can move this particular application to here and there, right? So I can just move it across, and whatever I want I can do. That is the concept of Java. And Java's greatest feature is platform independence. What is meant by that? If I write a Java program, if I create a class file, that class file can be given to this machine, can be given to another machine and all. So the people started thinking, rather than a tightly coupled virtual machine image. Remember, this is a blank virtual machine. Inside that you put an image. And what is the image you put? Cloudera virtual machine image you put. Similarly, Hortonworks virtual machine image you can put. Anything you like, you can put, right? That is the concept of a virtual machine. Whereas a container, if you create, that container will run just like an application, and this container can be ported to anywhere you want. You can create as many containers as you want. It is not tightly coupled, it is like a mobile home. You can move it, not like a fixed land and fixed home. And the greatest advantage is that, assume that this is your local machine. You created a container. You wrote your code, your talent or your ab initio or whatever it is, if they support Docker images or container images. And then you tested it and you run it. And it is taking a configuration file to connect to your development databases. And assume that you moved this to production. The container completely. The container internally contains ab initio, everything. So not only the code, the container is moving, just like the trucks are moving containers. And that container is moved to production. And you change your property file to point to production. Everything runs. No environmental problems. Nobody is going to complain that I don't have enough RAM, like every day he is telling, right? My Unix is running, they are not allocating RAM, they are not giving CPU. You tested it, you containerized it, and that container is working, and you moved that whole container. It is like moving a computer to another computer. So, containers change the entire world. And somebody needs to manage the containers. What is meant by managing the containers? Hey, how many containers I need for running this particular application? It seems that yesterday you wrote the program for 100 MB of file, but today 200 MB is coming from the provider. How this container will be capable? No, I need one more container to spawn dynamically when I need more power. Automatic. So you created a container management solution. Google invented it, and that is called Kubernetes. So Kubernetes manages the containers, and the containers will contain your code. Container can be spawned on demand, and this is the whole concept of cloud. In cloud, when you create an environment and you are telling that dynamically grow that particular environment, what cloud does is dynamically it will create containers for you without your knowledge. And that's what in Amazon you call it as ECS, Elastic Container Service. And if you want a Kubernetes service, you will use Amazon Elastic Kubernetes Service. When you combine Kubernetes and ECS, you got everything that you need. Why? Because every day, if you want a Spark program, you will create containers for Spark. You will create containers for Hadoop. You will create containers for whatever you like. And then you will expand it. And you will attach it to a Lambda, which means that it will allocate as many container instances as you want. Now, these are all open sources, completely free. Let us productionize it. Kubernetes, OpenShift has been taken, Red Hat has been taken, and the corresponding environment with a nice UI. These are all completely command based. So if you create a nice UI where you can allocate the containers and all, drag, drop using your mouse and all, you get OpenShift. And in that OpenShift, you can create your images. You can do whatever I want. So today, if I want to create a web application, if I want to create an HTTP REST application, I will just send an email to the OpenShift team, just give me a container. I am going to deploy my application onto that particular container. And that will be useful for some 10 users. And when the 100 users are coming, I will tell, spawn one more, spawn one more. I don't touch the code. I don't need to do anything. They don't need to do any configuration, because I already told that one container needs 2 GB. So when the other container is spawned, it will automatically allocate another 2 GB, another 2 GB, another 2 GB. The containers will grow as the demand grows. That's the whole concept of containers. And who is the best container-based software which came into the industry? Docker. Why that name Docker? In the shipyard, when your containers are coming, the containers will be moved here and there. So the container is moving from here to there, here to there. It's called a Docker. So what we are going to do is we are going to start installing Docker. Right? And once it is started, then I will tell you what it is going to work. So the first step is that I am going to go to the Safari and I am going to search for Docker Desktop for Mac. And please watch everything. There are 3 copies that we are getting recorded. So there should not be any question, and apply the common sense that, no questions now. Apply the common sense now.
You didn't share the screen.
Oh my God. Anyway, that is recorded so far, right? Is the sound is getting recorded? Of course, yeah. All right. No problem. I'm sharing now only. Okay, screen share, settings, right, Skype, and right, and is it shared? Please let me know, because now only I'm starting the sharing.
Yes.
Shared?
Oh. Yeah.
All right. So Docker Desktop for Mac, and then click on this. So you will see that from Docker Hub, you are getting the Docker Desktop for Mac, right? So we start here, the Docker Desktop for Mac, and then get Docker. Allow. You can see the DMG file is getting downloaded. It is a little bit slow. Please don't download now, because we are doing that. So it's getting downloaded, as you can see. Make sure your QuickTime is running and the Skype screen is shared. QuickTime is running on the top. This particular box is showing it. If it is gone, we can't do anything. We will rely on this. I have told you many times. Now we don't have time for all these things, right? When we are doing containers and you don't know how to run Skype, very bad, right? How will you survive in the software industry?
All set.
All right. So docker.dmg is downloaded, which means that now the Docker is ready to be installed. So I'm going to install the Docker. Okay. Remember, Docker is a software which is allowing you to manage the Docker images, which are also, Docker is also called as a container service. So we are installing Docker, and as you can see, the nice, beautiful symbol of ship, and just drag into applications. And Docker is now ready. So Docker is installed, you may not need to drag and drop into your Windows platform. Why? Because in Windows that concept is not there. Because it is Mac, you have to drag it, right? The Docker is running, and how will you know that the Docker is running? Just run the Docker and go to the preferences, because I want to show whether my Docker is running on the top. So let's start. Click on open, right? Privileged access, okay, and we need the password because it is the administrator rule. If you are logging into Windows as an administrator, it will not come, but in Mac, it is asking for it. And once it is there, then your Docker desktop is there. Okay, you have to create a Docker ID, and that will be used throughout your Docker programs. Create one at hub.docker.com. Click on that, and we are going to create one for Bhaskar, and I am going to use Bhaskar's email ID. Okay, it is nm.bhaskar@gmail.com, correct? Yeah. So what I'm going to do here, okay, I'm just moving this particular window, okay, closing it, and then click sign in, right? Sign up, because that's the first time, and give a Docker ID, right? So I'm going to give Passion Bhaskar, okay? I think it is unique. Passion Bhaskar, and email is yannam.bhaskar. Please make sure this is correct, gmail.com, okay? And let's give a password, okay? You select the password, don't give the Gmail password. Please select the password and remember the password, okay? So type the password and then create your ID, all right? So he typed the password. I'm not a robot. All right, click on sign up. Okay, there is a you are not reading what you shown. Come here, and please look at this. Okay, so go here, and then I will give you the password later. I am creating a password for him, and then I'm going to click on sign up. All right, and I'm going to save that particular password so that every time he doesn't have to remember. Where is that window? Right, your account is created, right? You can just check whatever is needed, but I don't think that is needed. Let me see whether it is going to check or not. And I can just click on sign, and what is the ID we created? Passion Bhaskar is the ID, and the password that you have given here, which I will give you later. Don't forget. Okay, it is not. Okay, account is not active, so you have to go to Yanam, and already the mail is there from Docker. I'm going to click on that, and I'm going to click on verify email address. Now the verification is success, and now you are going to go to the sign in and create ID, and this time let us give Passion as the password, right? All right, welcome back. Sign in with your Docker ID, it is telling, but here now you see Passion Bhaskar is created. So the Docker ID is created, right? The first thing that you have to do is that in Spark, please remember that we are covering two things today: Spark, Docker. In Spark, when there is a master and when there are workers, just like name node and data nodes, I want to do a word count of a file. Assume that in the code I am going to read this file from / let's say ABC directory. Our file is babynames.csv. Remember? I'm reading. You are submitting is from one of the machines. This is your client machine. Master is different, worker is different, client machine is different. When you give from the client machine, the code is going to get executed on workers. How the worker knows what is /abc/passion people? We are not installing Hadoop. If it is Hadoop, it is HDFS. Everybody can read it. So what is the first thing? The containers should share a directory like NFS. Go to the preferences. Go to the second tab, resources. Go to file sharing, and please look what all I told you, that container settings. How many GB you want whenever each container is getting created. All will be set. Since it is a 16 GB machine, there is no problem at all. If you don't have the enough memory, you will get an error at the time of startup. All right, you got those things. I'm going to go to the file sharing and look at that. All these are shared. No, I don't want this. I want to create a directory especially for my data. So what I'm going to do, I'm opening the host terminal. Remember, this is the host terminal, no relation with, I'm going to play with host, client, master, worker. Please follow with me. All right, so I'm going to start local machine now. And I'm going to create a directory called mkdir data. And if you look at cd data, and if you look at pwd, it is /users/yanum/data. That's the directory. What I'm going to do now is that, okay, I'm closing this, and I'm going to add one more directory, and I'm going to tell that, okay, I want users/yanum/data as a shared directory, and it is not shared yet. You created a volume. Anybody Unix? A volume in Unix is nothing but a disk that is attached. So you just attach the disk, that's all. When you create your container, at the time, you will tell that you will mount that to a particular directory. This is Unix. You need to know operating system, you need to know software, you need to know programming, you need to know everything. And that is why I'm taking this. So you will mount that drive at the time of creating the container. Why? Because tomorrow you may create another container who doesn't want that mount, unnecessary. Or this container may want another directory as a mount. So you just told that, okay, this is the first step of the Docker creation. These are all coming after 20, 30, 40 times of creation. Then I came to understand that, okay, this should be done at the first. You need to practice, spend time. All right, so apply and restart. Remember, it will take an effort, restart. And always, whenever you are doing anything with your Docker, you will see that the containers are getting animated onto the top. And always make sure when you get a message that a new update is there for Docker, you please make sure that it is updated, unlike your virtual machine and all. In virtual machine, when we get a new message, update is available, we won't go for it. Why? Because it takes a long time. This is just quick, very quick. So Docker is restarted now, and if you look now, this is already available. That is the first step. So my Docker is running. What is the guarantee that the Docker is running? That icon. If you don't want the Docker to be running, just you can click quick Docker desktop. And you can easily spend time on Kubernetes, and you can create kubecontrol and all, which is beyond the scope of our discussion. But once you learn this, I leave it to you. So everything is available, and once you know how to play with this, then immediately you can apply for an OpenShift account in your company and start playing with instances and create instances. All right, so Docker is created. Now what we are going to do, okay? So what usually I do is I am in data directory, where am I? I'm in user/run. I'm going to create mkdir my Docker world. And then I'm going to write cd my Docker world. So now I am in the host system. I created a directory. I didn't do anything magic. Now let us talk about how the containers work. Amazing. Very innovative strategy and approach. Whole world is changed by that. Never ever somebody could imagine running a Spark cluster on a local laptop, just like production. How the container will work. Tell me, a container, whenever you are starting, it is empty. And you will create a file now. Every container has its own file. Spelling very, very, very important. D capital, all the rest lowercase. So, if I create a container in my Docker world, I will create a directory called ABC. And inside the ABC directory, the first file I am going to create is a Docker file. What you need in a container? I need first an operating system, which is Linux, and lightweight, because we don't want heavy operating system with UI and all. A lightweight. Alpine Linux is a very lightweight system, like SUSE Linux, like Debian Linux and all. Even in Windows, you are going to do the same thing. All these steps are just the installation part for Windows that you need to do. Remaining everything is set. You created a Docker file and you told the Docker file, what is the first line you are going to write? From Alpine. You are going to write. What is this from Alpine will do? Somebody who invented Docker has created that Alpine already in the Docker hub or Docker registry. So, whenever you are using a Docker file, it will make a connection to the Docker registry where the whole world has kept Hadoop, Spark, every image free for you. But we are not going to do Spark now. We want operating system first. What Spark? How can I install Spark without operating system? And what is the best or most important tool that we want on this operating system? Java 8. So I am going to write from Java 8 Alpine. What it will do? It will import all that Alpine and it will create, and you will see the message that it is downloading very quick. It is lightweight. And then it is going to put Java 8 on it. Installed, no Java home, nothing you need to do. All done. One line. Inside this, next I am going to write, go to Apache site, bring Spark. Where? On the top of this layer. Now operating system is ready. You put the Spark on the top of it. Building a house, cement. Once you put that particular Spark, create your Spark home and all those kind of things. If you want any configuration changes, do all that configuration files. And then you are going to run this Docker file, one command. What it will do? Whatever you have written in the Docker file, 1, 2, 3, 4, 5, 6, like a script, Unix script. Tuck, 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 tuck. Once you created it, you created an image. Use that image to start an instance. And we are going to do that. So, what I am going to do is, my Docker world is a directory, and I am going to go there, and I am going to go to foroursun.com/passion. And please come down where the S is started, and you can see sparkmagic.tar. Always it will be there as a reference for you. Just click on that and let it download. Sparkmagic.tar. And as you can see, it's very quick 1 megabyte file which is going to do wonders for you. All right. The Hadoop distribution.zip, or if you are downloading Hadoop and you start installing, imagine the pain. All right, now you know in the this one, and I'm going to move it from the downloads folder, and I'm going to copy it here. tar xvf sparkmagic.tar. You got a directory called SparkMagic. I'm going to move all the things in the SparkMagic to here. and I'm going to delete the Spark Magic directory and the Spark Magic.tar directory. We don't need it. We installed and created. That shows you some idea. What I'm going to do is I'm going to create a Spark cluster, but before creating the Spark cluster, let's create something very simple and then we will build on the top of it. So here starts the fun. Go to the Spark container now. Remember I told you to create a directory, right? So Spark container is our directory. And you can see there is a PDF file for you to read. That is the Docker fundamentals.pdf. We are not bothered about that now. And what is the other file? Docker file. And there is a help.txt. Help.txt is for you to understand what is each line in the Docker file mean. So what I'm going to do is I'm going to open another window where I am going to keep this spark.txt. Let's take this one. And the help.txt I am going to show cd my docker world, right? And inside the my docker world, Spark container is the directory that I went in, and vi help.text is the directory. And I told you that we need a Docker file. So in this black window, I am going to write the vi Docker file. Anybody? What is the first line? From OpenJDK 8-Alpine. What it is doing? Give me the Alpine Linux operating system and give me Java 8 installed on the top of it. Second, please install APK is the installation script. Like Mac uses DMG, yum, all these are the tools for installation. In Alpine Unix or Alpine Linux, the installation is called APK, application kit or something. So run is a Docker word. In the Docker file, when you write run, you are telling that go to the command prompt without telling me and install this command. So it is going to install an update on the wget and tar bash. And then you can see it is downloading the Spark download into that particular OpenJDK Alpine. And then I am going to untar that and I am creating this particular directory and I am calling it as /spark. So this will be untarred and then I am moving the name into Spark and then I am deleting that particular downloaded file unnecessarily. 3 lines. And that is my Docker file. But very important, tomorrow when you are running this, you won't get anything and you will get full of errors. Why? This link that I took is available today. You have to make sure that this link that you are typing here is correct. How? Command C. Go to this particular window, open another command prompt, Command V, and press enter. File not found. That's exactly what I wanted to show you. It will not work. You told that you'll install operating system and you are telling that, okay, bring some file which is not there. So, first find out what is the correct link for Spark. So, Spark downloads, right? And go to the Spark downloads and I'm going to take the latest. 2.4.5 is the latest, but we want 2.4.4, which is the most stable version. 2.4.5 is last week. Okay. So, press enter. So, you will see that you are going to the Spark release. Okay. Let us click on downloads. Okay. So, in the downloads, you will see it is the latest version is 3.0 or 2.4.5, which is February 5, 2020. We want 2.4.4 because we don't want to get into errors. So just I'm taking this one. So Spark release archives, click on that. And I want 2.4.4. Now I got this particular link, okay, and I'm going to make it big. And you know that Spark 2.4.4 bin with Hadoop is the link. Remember that Hadoop is just the name. We are not installing Hadoop, we are installing Spark. And now I am going to right click and I am going to take copy link. And now I am coming back here. And I am going to write run wget, delete this particular thing, okay? And please think throughout. Remember the file name. That file name should be exactly same as what you are referring in the next lines. Okay. So I am going to delete this one, right? And I'm going to paste it. Look, spark-244 bin Hadoop 2.7.tgz. That should be exactly same as what you see there. Can you just come? So we are going to use exactly the same command, right? So all right. So what we are going to do is that file. My mouse is that highlighter is not working. This one is exactly same as this file. You should apply common sense. If you write there something else and then you are trying to tar it, of course you know what will happen, right? It will not work. So that's my Docker file. So see, tell me if you want to install first Hadoop and then Spark, what you will do? You will write another one line there on the top to install Hadoop. But remember, when you're installing Hadoop, you have to manage how to SSH, and also you'll have to install SSH, you'll have to install all the other tools, everything, step by step you have to do. Your Docker file in the future may contain 100 lines, 200 lines, which will create a beautiful, fully available cluster. All right, so now I am coming out. I have the Docker file, and if you go to my help.txt, wherever you see the word local, what does that mean? You should execute that command from your host. Whenever you see some command called docker : I will tell you where you have to execute. So please look, I am going to build it and enjoy what is happening. I'm going to call it as Ravi/Spark : latest. And I'm telling with a dot, what does that mean? I'm telling Docker, take the Docker file from the current directory and install it. You can even take the Docker file from GitLab or GitHub and then execute it. All that facilities are there. So Control C, and I'm coming here. I am inside the Spark container and I am writing my first command. And look what is happening. So you will know the magic now. It is connecting to the Docker registry. It is installing me the operating system layer by layer. It is installing what all required. It is going to run through all the downloads of the Spark. And it is going to finally create that particular Spark directory. And once it is created, we are going to create a container image. The image is getting created now, and then now we are going to create the container. So 95, 97, 100%, yes, it is downloaded. It is running the next command. It is running in that layer that I told you, layer by layer, and everything completed. How much time? All right. Once it is completed, what we are going to do, we are going back to that help.txt. That is why I gave you the help.txt. And in the help.txt, again, in the local machine, I am running it. And I am going to go inside my machine now by /bin/sh, which is the last parameter. And please look that I am going to call the machine that I am going to create as Spark Master. So my machine will be known as Spark Master. So inside my Mac, now I created a computer which is called a Spark Master, which is a container. And that Spark Master, I want outside people to access using a port. That's what this is doing. 8080:8080 means from my browser, from the operating system host browser, when I use 8080, please redirect my request to Docker's 8080. It's called a tunneling. So you are doing the tunneling there. And you are calling it as master, this one. And you are going to execute it. So let's execute it. And I'm going to copy that. And clear the screen here because the image is already ready. Remember, you cannot do this without creating the image. First, you have to create the image, and you did it, and you got your prompt, and you are inside the machine now. You cannot see it. It is running. The container is ready. And if you look at ls now, you will see that your Spark should be there because you told that create that particular Spark after untarring it and then moving it, and your Spark machine is now ready. Now the Spark machine is ready, the container is ready. We have to do some things. Okay, so come out or go inside the Docker, and so whenever I am saying inside the Docker, I mean that hash symbol. That means you are inside the machine. When I say local, what does it mean? This is local. Control D, that I came out of that machine. That is the local. Clear? So I am going to execute this again and go inside this virtual machine. Inside the container. Okay? We should not say virtual machine. All right. What I am going to do is now I am going to spin a master. How will I do the master? I am going to paste that, and please look at that. I created a Spark directory inside the bin, Spark class. I am going to call it as master, and I am going to tell that, okay, use some IP that I want, and the port is 707077, and the web UI port is 8080. So I am running Spark now, and web UI port, please listen, 8080. Why that 8080? There is a significance because that 8080 is already tunneled in the previous command. Please understand. Okay, in the previous command you tunneled it. In the previous command you tunneled 7077 also. That means from my Mac browser I can access localhost 8080 and localhost 7077, which will be tunneled to the Spark's container. Otherwise, in no way you can touch the container. That's called port exposure or tunneling. In Putty also you can do the same thing. All right. So if suppose you are doing this, and I'm going to change this host name to Spark Master. I think we gave the name as Spark Master, I think, right? Minus IP. Otherwise, leave it. The master started and the Spark Master is started. And what is the proof that your Spark Master is started? Go to the browser now and type localhost, not 7077. 7077 is Spark's port. 8080, the web UI is what we want, right? And that shows that you created your Spark cluster. It took 20 minutes, right? That is because I'm teaching you. If suppose you know it already, 2 minutes, you created the Spark. That's the magic of containers. All right, Spark Master is there. What is the use? No use at all. Why no use at all? Where is the worker? Spark Master and worker. Master is like a name node. Who is going to manage the resources, manage everything for you? What I want is workers. So I am going to go back to my command now, right? New window with the profile Spark container via help.txt, right? And then I'm going to stop all these things. And I'm going to remove that Spark Master. So Control C, Control D. Whenever you see the Docker command, what does it mean? It means that you are stopping. There is nothing is there. No problem. Remove. I think it is already removed. Yeah. These are all the Docker commands. How will you get the Docker commands? Just to help. Remember the HDFS shell command. Similarly, Docker shell commands. That's all. For example, Docker image ls, I think. Yeah. You will see the images. Look. OpenJDK and Ravi/Spark are the images currently available. So you can use the commands in order to run the this one. Okay, so clear the screen, go back. All right, now where is our help.txt? And that help.txt is your Bible. All right, what we need to do? We need to create a worker. But now, how the master will communicate with the worker? Remember, you are not in your computer. You are creating a network infrastructure. So what you need to do? You have to create a network only the containers will use. And then after creating the network, you will tell that, okay, master attached to this network, worker attached to the network. Now the master can talk with the worker. All right. what we are going to do now is we are going to create the network. How will you create the network? I am going to call this as Spark network. Go there and remember it is a Docker command. Whenever you see the word Docker something, that means you should execute it on your local. You can see that it gave you a network ID and you created a network. So Docker created a network for you. And after creating that, the next command is now we are going to create the master on that network. And how will you do that? Use the network in the local and create it. And please look at this option. All the remaining are same, but I am telling that this is to be created on the network we have just created. And please don't be foolish here. Without creating the network, don't try this command. It will not work. All right. So if suppose you are running this, Control C, and then come here, and then Command V. And now you created the master. All right, what you need to do? Open another command prompt now. What an interesting thing. Look. Homebrew. And I'm going to change this one. Different color. CD. My Docker Vault. CD. Spark. You go to the same container, same directory. And now can you tell me what I am going to do? I am going to run the next command now, which is creating a worker. And go to the help.txt, create a worker, and you can see worker is using the same image as the master. But what is the difference? Can you tell me what is the difference? There is no port and there is no 7077 for a worker. So what we are going to do? We are going inside the worker. And I am going to write here, Control V. What is happening? It is creating a worker. Remember, worker's port is not exposed. Whose port is exposed? Master's. Press enter. And you are now into two containers, the black screen and the green screen. Right. Now let us start the master in the master. And that should be in this particular command prompt. I started the master. I have been elected as the leader and this is the master. And now I am going back to this other one. Yeah, here. And where is our help? Let us run this thing and please look at the difference. A great difference is there. This command and this command. This is running the master, but this is running the worker. Same network. And the worker is connecting to Spark Master 7077. And it will be able to connect now. Why? Because both are in the same network. So I am going to use Control C. And I am going to go here. And I am going to type Control V. Successfully registered with the master. And look at the last line in the master node. Registered the worker. Now you created your Spark cluster with a master and a worker.
But you didn't use your network ID in any of this.
Please check, Bhaskar. Please check. Please check whether I used a network or not when I started it. Okay, it's all there in the help, right? Huh? When I write Spark Master :77, and I already added Spark Master to this particular network, and I exposed this particular port. It is available from everywhere, and it is connecting to the port, right? All right, now what we can do? We have to run a particular program. So what we can do is that we can create either a normal driver machine or you can run a particular code inside this particular thing at all. So what we can do is we will start a driver program now. Remember, master, worker, and the client, right? Client is also called as a driver. The driver is called Spark driver. And it is also in the same network because the driver should communicate. So let's do that. Control C. I am going to open another command prompt now, which is for the driver. So how many command prompts, how many terminals we have? One for the master, one for the driver, one for our help. And now I am adding the fourth one for the client. So new window. And I am going to go to a red color one, and I go here, go to the same directory, cd my docker world, and cd spark container ls. After that, what I'm going to do is type the command that you want to, which is, oh, it copied 2 times. A driver program is getting created. And after the driver program, what we will do? We will run a code to submit to the master our first program, which is called an example pi, to calculate the value of pi. Copy that. Remember Hadoop MapReduce word count example that was available in the Hadoop library? Spark gives you calculating the value of pi using some machine learning algorithms. And that is an example. I'm going to take that example and I'm going to go to my red screen where I am running my client, and I'm going to tell that submit my program to this one. So there is a copy, there is a this one, a mistake in the copied command. So go there, and in the beginning, oh, half is not copied. Where is that? Go to the help, the blue screen, this. Copy. I think there is a problem with this line. So let me just go here and make sure that it is copied into a same line. Otherwise, it is taking the second line as another line, right? So right, and copy that. This all be careful when you are running it. All right, go to this red window and let's type this, right? With a very huge number of partitions, the program is running. It is submitting the code to our Spark cluster that we have created. It is running the algorithm 1000 iterations, which is pretty complex. And it is going to calculate the value of pi. Good. And you got the value of pi, which means that the program successfully executed. And what's the proof? Go to your client program now, go to the same host. Now you see a worker, and you will see a completed applications, which is Spark Pi. You created the Spark master. This is industry also do not do. This is the ultimate thing that is happening in the big data world, and you know how to do it now. So you created a master, you created a worker, and you created a client, and you submitted a program from the client. Any program that you get tomorrow, all you need to do is this. That's how you'll create it. Now let us do a little bit more magic before we close off, right? So I'm going to close this particular browser. I'm going to close this Windows. Control D. Close this window. Whenever we want, we will open it. Escape, Shift CC. I don't want it. This is useless window. And this one, where our master is running, Control C, and then Control D came out, and I'm closing this. And we have Control C, Control D. Because the master is stopped before the client, you got exceptions. Actually, client should be closed before the master, but don't worry, you can play whatever you like because it takes hardly 2 minutes for you to start a Spark cluster. And now I'm going to go to the clear screen, and I'm going to run a command. And remember this command and do it very carefully. The command is going to delete everything, okay, including the network. It is called docker system prune. So I'm going to type that particular command. it will stop everything, and it is asking you the confirmation why all are deleted. Right? I have deleted everything now. And we are going to start something very new to show you the ultimate facilities by which you will use containers. So I'm opening another window. I deleted everything. Okay. And now if I go to localhost 8080, what will happen? As you know, all are clean now. I'm going to this particular one and go to my Docker world and then go to the network one with this Spark container with Compose. Often when you want to create a master and worker, as I told you, dynamism is very important. Sometimes you will be writing a pie example where you needed only one master and one worker. It is okay that you created one window, typed all the commands. Right? I don't want to type all these commands. I want to make the things clean. So, let me first show you my Docker file in this directory. Remember, this is like a separate program. So, in this directory, I am taking all these things. I am getting this one. I am doing. And now, whatever you typed for starting the master, remember that port, network and all those things? I am copying it into this particular directory in the image. So, in my local machine, already I have got startmaster.sh. So, at the time of creating the image, I am telling that copy the script to that container rather than I am typing it. Understand? So, if you look at the vi startmaster.sh, you will see exactly the same command that we did. Only thing is that it is parameterized now. Instead of writing web UI port as 8080 and master port as 7077, I have just parameterized it. That is the start.sh and then start worker.sh. That's it. Correct? And now you can see another additional file called docker compose.yaml file. In the YAML file, I am telling that please create me the image. The host name should be this. Remember this command that we have written and we have to create a network before this. Attach it to a network and we are giving the variable names which we used in the start.sh and then create a worker. So I am writing all that things. And remember the first step we did? User / yanum / data is shared. I am telling that I will change it. User / yanum / data. If I want to take anything, I will write in my code /local. When I write /local, it should bring the data from you mapped it. That's why we did it there. So I'm going there and I'm going to change it. And I'm going to call it as. Otherwise, we could have restarted the machine and your video could have been gone. User / yanum / data. So inside that everywhere. So if I want to read babynames.csv, in my local, I will put inside yanum / data that babynames.csv, and in my code, I will refer it as /local / babynames.csv. Got it? You cannot do this unless you did that first step. And then, when you created the virtual machine, you told that you want a bridge network. We will create a bridge network, and that is how you will create a bridge network. And now the magic is coming here. What I am going to do is, I am going to create a network. Again, open the help.txt in our blue screen. So, new window with profile, ocean, and go to cd my docker world and cd spark container. This is a different directory with compose, and inside that I am going to write vi help.txt. As I told you, first we have to create the network. So how will you create the network? Docker network create spark underscore network. Okay, it should be Spark underscore network. Okay, Spark underscore network. Okay, intentionally some errors are there some places because I don't want you to get everything straight unless experimenting. So you created the network now because earlier we pruned it, everything was deleted. And after creating the network, go to that help text and I'm going to write something. First we have to build it, right? So we will build the image and after that we are going to do the, after building the image we are going to create all these things, right? So first we have to create it and then build it, right? So let us type a command and see whether images are existing or not. What is the command for seeing the images? Docker ls images, right? No, docker ls image. It is there. Image is not deleted. If you want, you can delete it. Let's do it fast. How will you delete all the images? There is a command that I have given in the help.txt, which is this one. Docker RMI, docker images -aq, and if you type this and then you delete, everything will be deleted. All clean. And if suppose now you write docker image ls, nothing is available. So let's create the image. And what is the command for creating the image? It is there in the beginning to create the image, which is docker build, right? So go back to the command prompt and make sure you created the image. It should be in the local machine, right? Docker command. As you can see, everything is going to happen now. Again, watch the way containers work. Each layer, because the image is not there. So once you create the image, you're good. If you make any changes, then you will have to redo it. You have to delete it and you have to delete it. So it's downloading Spark now. All right. Moving. It's running the command. Everything done. And please look, what is the exchange? Why I didn't use the old image? Because in the old image that start, master and all are not there. That's why I told you when you made the changes, you have added that start master and start worker, all that commands. So image is ready. And after the image is ready, please look at what I am going to do. And this is the most powerful line, I would say, what containers are providing you. Can you guess what it is? I am telling that master is 1, but scale it up. And press enter. No separate window. Nothing. And now I am going to write localhost 8080. Aha. A master with the 3 workers. This is Docker Compose. Docker file and Docker Compose. Nothing is visible outside. All running internally. So you created the Docker now with 1 master and this one. Now what do you want? Huh? And this is client. Ultimate. Right. And in the client, what is the type of language you are going to use? Scala. And you are going to write Maven. All right. Very good. So what I want to do now is cd my docker world ls. I want Scala, I want SBD, I want Maven. vi. Let us close this text and we will go to the other directory. What is that? cd Scala Spark Maven and vi help.txt. build with Scala version, and then I'm going to run it. But this time I want to SFTP from FileZilla if I want to move something from my local, because code or something I want to move. So I'm going to create that one, and I'm going to build that image. SBT and this one. So go here, and what is the command? And this is what we have done in 3 classes. Installing SBT, installing Scala. Don't worry about a move command error there, which is coming in red color. So we created the client now. Remember, the master and 3 workers are running. So we have the architecture here. The container is now having a master, a worker 1, worker 2, worker 3. And now I have the Scala, SBT, and Maven, and Spark, because I have to submit inside this one. And after I am going to write the program, I am going to submit it into my Spark cluster. So Scala is getting installed. Don't worry about the command. Maven is getting installed. All done. My image is now ready. Once the image is ready, we'll go back and we will start it. There is a command that we need to execute to understand what is our network name, because we have to attach this particular machine to the network. Remember, Spark-network is what we have created. But the way in which Docker does is that it will add the container name to that one. So I'm going to get the network name by writing Docker network ls. Let us see what is the name of that particular network. Docker network ls, correct? Yeah. Yes. And look at this. This is the name of the network because it is attached. All right. Now I am going back to my help.txt and I have to give Docker rm network, and I am going to what is that? This one. So I am going to change this particular word here. Please look at this. Here I am going to paste that value. Docker -it rm. So let's do one thing. I'll copy this one first. Control C. Go back. Where's our window? Okay. Control V. And what is the network name? Just copy this one, which is the network name. Control C. Control V. And remaining part of your command. The remaining part of your command is this one. And look at that -v again, where the volume is. Remember, there is no Docker compose .yaml for this particular one. That is why I am manually doing -v. And that ravshankar/data has to be changed. So now you built it and you are creating your build/bash. But before going there, what I'm going to do, go to a new window here, right? And in Spark data, I have got, you like babynames.csv, passionpeople.csv, okay? So what I'm going to do, passionpeople.csv, and control A is a big file, very big file. Oh, very big file. Okay. Right click, very big file, right click. Download the linked file as passionfile.csv. Instead of this one, I am going to go to Yanam. enum/data. And I'm going to save it as passionpeople.csv. Remember, it is in the local. And when I save it in the local, where it will be available? /local, it will be available. All right. Now what we are going to do, I'm going to run this particular code here, right? What's the problem? You got it? Is the Scala available? Is SBD available? Yes. Is Maven available? Yes. Is Java available? Yes. All these are there. What is the last step? Let us write a program. And that program, we are going to move it. So I am going to open FileZilla now, because I need to move that into this Docker image. That's why I opened the port -22. But before that, you have to set a password. Docker containers are having the ID root, but no password. So how to do? Password. And I'm going to give the password as passion1234. Okay, remember, P capital. Again, one more time. Passion1234. All right. After that, what we need to do? We have to change a config file, because since Docker is assuming that there is no password, password login is not supported. We have to make it as yes. How? Go to the help.txt that you have. Where is the help.txt? I close that window. Okay. So we can open another one. New window with the profile, the blue color. Okay. CD. CD my Docker world, and then CD Scala SBT vi help.txt. Every directory has got, right? And the place to change is this particular file. Control C, vi, Control V, and I'm going to come to this below, and you look at this permit login. You will understand. Authentication, permit login, prohibit password. I don't want that. You don't know how many months I took for figuring this out. Nowhere it is written. I will write yes, permit login equal to yes. And after that, there is one more step that you need to do. You have to restart the SSH service. So go to the help again, vi help.txt, and inside the help.txt, you have to write this command first. Good. And you have to write the last command, which is etc/init/sshd restart, because then only the restart will be happening. Look at this. Yes, it is restarted. Now I will go to FileZilla. FileZilla cannot be opened. This is a problem with FileZilla in the latest version for Mac. So FileZilla client, and download the latest FileZilla client. Oh, sorry. Download the FileZilla client. Yeah, Srinivas. FileZilla client, and for Mac, download FileZilla client Mac. Right? Press enter, and then press enter, and then download FileZilla client, and then download. Right? Allow. Okay, and now I'm going to install it. All right, FileZilla, I'm starting it from the downloads directory. Click open. It should open now. Yes, 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 yes. All right, FileZilla is open now. And after FileZilla is open, what I'm going to do? Please look, SFTP, localhost. The username, root, and remember we changed the password as passion1234. Port, remember the port I exposed is 2222, and then click connect. Beautiful. You are now inside the Docker. Now what I'm going to do is that inside my directory, my Docker world, there is a folder, my Docker world, and inside the my Docker world, if you look, there is this sample folder on the left hand side, right? Sample. I'm going to drag it to the right hand side. So where I'm moving? I'm moving to the new machine that we have created, the code that I have written. So sample is here now. Now I go back to the Docker. We don't need FileZilla. Quit FileZilla, right? We don't need, sorry, ls. Look at this. Where is sample? Yeah. No. Scala SBT Maven. Where did it move? I think it went into some directory. Okay. Let us reconnect. Password is passion1234. Okay. It is there. Oh, it went inside the root. No, I want it here. Okay. So it went inside the root. Okay. So I am going to add it. And let's see, ls. Yes, sample is there. So cd / sample. vi main / scala / example that scala. Never ever write Spark context in your program because we were using Cloudera virtual machine. That is why we use Spark context. The latest Spark from 2.0 supports Spark session. You should always use Spark session. So when you start Spark, if you are starting version 2.0 onwards, you will not see the line Spark context available as SC, and you should not use it. That's old standard. You should be using Spark session. So create a Spark session. But from the Spark session, you can get a Spark context if you need it. That is why I commented that line to show you how to get a Spark context from the Spark session. And look, /local / passionpeople.csv. Everything is mounted. When I write /local, it is referring to the user /yanam /data. Why? Because we mapped it. And I'm going to read it. And I created a data frame. Remember the pain that you had in the last class to find out the row header and then remove the header and then read the values and all those kind of things? All that things are getting eliminated now in the Spark latest version. Spark.read.format, it knows it is CSV. Option, header is true, that means I am providing a header file. Okay, infer schema equal to true, that means automatically find out whether it is an integer, whether it is a string or not. And then show me 10 values of that. This is how you will manage it. Once you get the data frame, everything is in your control. Practice on the data frame functions, that's all. And this is how you will write a main program. And after writing the main program, what you are going to do is, you will have a build.sbt in the file, bs build.sbt. In the build.sbt, I told what is the dependency. It is depending on 2.4.4 version. And I am telling that my class name is com.passion.example. Right? After doing this, all I need to know is, see the beauty, sbt assembly. And when you write sbt assembly, it is going to run that build.sbt, taking your code and create one uber jar file. What is meant by uber jar file? One fat jar. Otherwise, you will die by putting minus jars equal to all dependency files in your Spark program. And that is a very painful task. So I have created this SBT in such a way that one jar file which compiles, it will be big size, but no problem. It will be one sized, all dependencies packaged, and I am going to submit that jar file to the Spark cluster that we have created, and we should get the output. So it is now downloading, compiling. What is the difference between and Maven or SBT? Whenever you write Maven or SBT, it will bring the dependent jar files from the internet. But when you use and, you will create a map reduce reference library and will create all the copies. Tightly coupled. Here is this program. Anywhere you want, you can take it. It will download whichever is wanted. It will create SHA-1 signature. This is for Jenkins integration for CI and CD, continuous integration. And you can check it when you move into Jenkins that whether the SHA is matching or not, otherwise disapprove it, whether it is coming from the actual developer or not. Okay, that's beyond the scope again. And now you are creating that SHA directory, SHA file, and finally you will see it is combining 630 plus 370 files into one jar files, so that you got the beauty of sending only one jar file. So the build is successful and you got everything, and total time is this. And where is this file available? It will be available inside target. The target directory was not there earlier, and inside the target it will create your Scala version, and you will see something there, Spark CSV assembly 10.jar, one jar file. And what I am now going to do is I am going to submit this into our Spark cluster, and I am going to create the program. So from the client we are submitting to the master and 3 workers. How will you do that? Go to that help, which is the last line, Spark bin/star localhost 7077. Why localhost? Because you already exposed it, right? Right. Control C, and Spark CSV assembly is the file that we have just created. And where are we going to do? We are going to go here and submit that and run our first Spark program against a true cluster in production. You are not going to get even this facility in your companies. And it should read that local if the mapping is correct, and it should read that passionpeople.csv file, and it should show you the schema and the first 10 rows. df.show10 is the code that I have written. So you can see now it is working. And if you go here and if you go to the local host 8080, now you will see that your application is running, and you can see how many threads it is taking, how many cores it is taking, and if everything is okay, it is going to show you the top 10 rows of your data. And somewhere I wrote df.print schema, which is automatically inferred the schema. You create the data frame. Never use RDDs. RDDs are low level abstractions. RDDs I gave you just like MapReduce to understand the internals of Spark. You should be using data frames always, and you should manipulate it. So as an exercise of writing the program, since you got everything, sample program, how to submit it, everything is there. What you can do is go to forourson.com, right? forourson.com/passion. And press enter, and then go to the Spark nodes, which is almost on the top, and inside the Spark nodes go to the day 1. You will see what is the master build SBT template if you want to refer, and there is one more called Spark and Scala, the part 3 workbook. Inside passionpeople.csv already we created it, and it has got all this data, and it is telling you almost all the data frame operations. Question names are not Q1, Q2 like last time. It is T1, T2. So in the solution that I gave you, Spark code.tar, if you untar it, you will see T1, T2, T3 for part 3. That is the solutions for this. Okay. So Spark cluster, containers, and if you go to Amazon, and if you log into Amazon, if you see AMIs, Amazon images, Cisco will give you WebEx based AMI. Cisco will give you something, some of their application. Ab initio may give you their application as an AMI. And if you create an AMI and create an instance, what you're basically doing is creating an image and creating the container, right? This is the world, and I don't have anything, and I don't know anything more. Okay, and I never attempted this. This is the first time I'm attempting. So the things that you have mastered are not simple. Okay. And these are the ways to go there. It needs hectic hard work, and then you reach that expertise. But once you reach it, you'll enjoy your rest of the life career. So finally, what we can do, we can just go there and stop all our Spark clusters, Control D, right? everything is Control D, just force cluster it, and our beautiful screen where you had this 3 workers and this one exceptionally well it is working, and you will see all the logs, everything that you need, worker 1, worker 2, worker 3, and you can just close that as well so that it is there. And I don't want to reuse this thing because now you got everything is there, so you know what is a command that I'm going to type. Control D, yes, absolutely. Okay, because these are all the things, because I worked until 2:30 yesterday because of one problem to help you out to make sure that everything is solid. So I want that from your side as well, right? So vi cd cd spark container and vi help.txt, and what we are going to do is we are going to prune all these completely so that you can start from the scratch. Control V, and all the images and everything is there, and vi help.txt. We will delete the images as well so that you can start with the first image, right? Otherwise it will mix up with your all the things. All the images are also deleted. Now your system is back. You didn't change your profile. You created a cluster. You executed a program. You finished it. This is the actual life of a modern software programmer. Whenever you want, you create a Docker image and you will run it and you will kill it and you will change it. You will update it. You will do all kinds of stuff on that, right? Now, one more thing to tell you is that, yeah, so I have already mentioned to you how to configure the data directory and everything. All right, save it.